really quickly, let's just remember basic electric theory. There's going to be a power supply, there's going to be a switch, and there's going to be work being done. When you draw it, you would have a power supply, a switch, and work being done. So here we're showing a closed switch. The loop is closed. The electrons can flow and do the work. On this side, we're showing the switch is open. The bulb is not lit. There's no work being done. So that's the difference between open and closed switch. In the corner of all electrical drawings, you'll find notes and legends. Notes here indicate that the machine is shown in first ball cycle with no power applied. And the bin switch open shows there are less than 10 pins. On the legend, we can see that all the switches have an abbreviation. CB is the master circuit breaker. T, table. S, switch. All the connection points, any plug on the machine has an abbreviation. Of course, we know the C1 plug, the C2A plug, the table cable, the sweep motor, the table motor, etc., etc. All of the control switches, the buttons in the chassis, everybody has their own abbreviation, so you know what switch we're talking about when we're inside the drawing. All right, first let's look at the power circuits. And remember that your chassis tester is pretending to be the pin setter and the control box. So not all plugs will be used or need to be used, depending on how fancy you want to make your tester, how many functions of your chassis you want to test. So here we'll start with where the power is coming in. This is your main plug from the ceiling or the wall or wherever the pin setter plugs into. This is the main plug coming in. Of course, the black wire is the hottie, the white wire is the neutral, the green is the earth ground screw. The main hots coming into the chassis are 47, 41, and 42. And then, like here, it runs out of the chassis as 18J back to the mechanic circuit breaker and returns as 26B, and then goes through the chassis circuit breaker and then waits for the manager's relay to power up the machine. That's going to be the T1 transformer. That symbol right there is just a transformer. A transformer transforms energy up or down, increases or decreases its voltage. In our case, it's decreasing the voltage. And then the others are on the hot side of the manager's control switch. The T3, T4 are on the other side, as well as the T2 gets its own circuit breaker. So when the M relay is powered, it powers up the T1 primary, which starts the machine. Also notice the tie-in right behind the M relay, which runs down, 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 and turns on the pit light, as well as the pit motor with the back end relay. So powering up the T1 primary powers up the machine and gets it ready for a bowler. Now the terminal strip is the neutrals all come to TS1A1. But they exit the chassis looking for the terminal strip through the C1 plug. Here's one 16. There's 13. If we go down, here's 34. And here's 21. So all these are looking for neutral. And that's the other side of our, we've got the positive, the negative, a switch, and work being done. All right, let's look at the back end motor circuit here for just a moment. Since we're not going to really, there's no need to put an actual motor inside your chassis tester. You just need a light to indicate that the chassis has turned on and is supplying 110 volts to your pit motor. So basically you can take one half of your test lamp and goes straight to the neutral side. And then instead of the windings of the motor, you would just have a light bulb. And that would go straight to 45W out of the C1 plug, because that's inside the chassis. The back end relay is inside the chassis, and that comes out of the chassis at 45W in the C1, and then that would just go straight to your bulb, straight to the neutral. So a lot of these connections, as well as the start circuit, that's inside the motor. So there's a capacitor and a centrifugal switch inside the motor itself, which will run the start windings. So for the back end motor, all we need is a bulb that tells it that relay is working. All right, the table motor will actually be simulated by a synchronous motor. So the main windings are going to be simulated by a synchronous motor. Take one of the wires straight to the neutral. The other wire is going to get its power from 31A. And that will run the motor. When the chassis goes to run the table, it will spin the synchronous motor. Now we still want to test the start windings. So put a lamp in, join it with the power coming out of 31A for the hot side, and then the neutral side, get your neutral from 32E. And that should be the start circuit. We really don't need to sample the braking circuit. We can see if the braking circuit is not working. Chances are pretty good. If the start circuit is running, the braking circuit is running as well. But that way, when the lamp will light up. There is no centrifugal switch, so the lamp, of course, will stay lit the whole time that the synchronous motor is running. But at least we know that the chassis was supplying a neutral to the start windings to get the table motor running. For the spot relay, to see when it's in spot cycle, make sure it's pulling in the spot relay. One leg of your lamp goes straight to the neutral. The hot side is going to come in through 36Y. And that would indicate that the machine is in spot cycle. All right, let's talk sweep motor and MP chassis. Now again, this is MP chassis with sweep reverse. If your center doesn't use sweep reverse, or if you're in the Alco chassis, this may not apply to you. But again, refer to the drawing and build your own chassis tester according to how your machines are wired. Again, now because ours is going to be fancy with little cams and actual motors, the main is going to be our synchronous motor. So one goes straight to neutral, the other one is going to come out as 22J. That's what's going to power our little motor. So we're going to steal off of 22J, as you see here, after the overload. It goes out center terminal, down to the terminal strip, over to the mechanics terminal strip to the mechanics, and all that does is flip the polarity of the start winding, so we can spin the motor in reverse. That's all you're doing with your switch, is flipping the winding. Well, now they gave the chassis can do the same thing. The chassis can flip the winding. And again, we get the motor running with just a simple running of the cam switch, that will run our little synchronous motor, but we do want proof of life of the start circuit and that this loop is working. So take the hot side from your 22J and then get the neutral from 24T, because that's coming down the back side of the mechanics sweep reverse switch. So again, if we follow the hot circuit in the pin setter, it will go into the motor, come back out of the motor as the center terminal, back to the mechanics box, where it catches the sweep reverse, goes into the motor, back into the chassis through 18, out as 27, into the motor, into the sweep motor, back out through Z, into the chassis as 26, back out of the chassis as 17, into the mechanics reverse, back to 24T, where it meets the contact inside the chassis for the start circuit, and eventually to 21D to find ground. Remember, we had all those grounds that wanted to find their way back into the chassis. That was one of them. It goes straight to the sweep contact, but on the bottom stack for the start brake circuit. So it's nice to have your chassis tester be able to test this M2 relay inside the chassis, because that's what's flipping your sweep reverse. Now, whether or not your chassis tester is going to be able to induce that, a gutter ball cycle, etc., that's a different story. That where we're just doing a proof of life. We're not going to hook it to the scoring at all. Just we want to make sure that this circuit is running with a light. So we'll have an actual motor for the windings, but just a light for the start circuit to prove that this works. So running the sweep reverse for mine is just going to shut the light off, is all it will do, because I'm not hooking up the reverse. All it would do is relight the light, because the light doesn't care if it's which polarity it is, it's still going to light up. But for the motor, it makes a difference which way it kicks it to get it going. So that's your sweep reverse circuit. Again, we're just going to do a bulb to prove that the M2 and the in and the out of the chassis is working as it should. The braking circuit along the bottom, we're really not too worried about. We're not putting in capacitors and all that. I really don't need to test all that. So build your chassis tester according to how your machines are wired.